Okay, so a quick review. I want you to do the two try these up at the top. We've already done these. So I want you to do the two try these up at the top. I want you to write the GCF of those problems. Go ahead. Okay, so on try these number 1, I want to find out what the biggest number that divides into 8 and 24 is. What's the biggest number that divides into both of those? 8. Good. So I take an 8 out, and then out of x to the third and x to the second, what's the biggest number of x's I can take out? 2x's, x squared. So 8x squared would be my GCF. Okay, I'll try these number 2. Okay, biggest number I can divide out of 4, 12, and negative 8. Can divide a 4 out, right? Then I have 3x's, 2x's, and a single x, so I can take a single x out. So 4x is my GCF there. Okay, so let's actually talk about factoring. Okay? This whole unit that we're getting ready to learn about is all about factoring. And I want you guys to know that factoring is the exact opposite. Okay, factoring is the exact opposite of distribution, of multiplication. Okay? Factoring is the exact opposite of distribution or multiplication. So, I want you guys to try this first example. You should definitely be able to get the first 2 points about how is this similar and how is it different. The third one's going to be a little bit of a stretch, but I want you to try, okay? I want you to try to take the GCF out, arming yourself with the knowledge that factoring is the opposite of distribution. So you are taking a worked out problem and you're trying to make a distribution problem by factoring out a GCF. So I want you guys to try through those first 3 bullets there, okay? So go ahead. Okay, so somebody tell me, how is this problem similar to all of the GCF problems we've done in the past? What? You find the GCF of what? You've never been working with polynomials before. What do we call those little pieces? Terms, okay? So you could say several terms. Oops. Several terms. They have numbers and variables, right? Numbers and variables. How is it different?
It's an equation.
Okay, it's not an equation. It doesn't have an equal sign.
It's a comma.
What is it called when it doesn't have an equal sign?
That's not what it's called.
What? No. Expression. Okay, so now it's an expression versus what did it used to have? Just commas, right? So they used to be separated by commas. Now they're separated by addition and subtraction. So how is it different? Addition and subtraction. Does addition have 2 T's in it? Just 1 T, right? It looks wrong to me. Okay, good. I can spell. I knew it. All right, so use what we know about factoring to factor the polynomial. So we don't know much about factoring, but we know that factoring is the opposite of distribution. So usually I would be taking something out front of a set of parentheses and multiplying it in. Now I want to do the reverse of that. I want to divide something out of all of these pieces, okay? So all of these pieces up here, I want to divide something out. So I want to find the biggest thing that I can divide out of all of them. So what's the biggest number I can divide out of 3, 12, and 15? 3. And if I have 3 x's, 2 x's, and a single x, how many x's can I take out? Just a single x. So my GCF is 3x. Now all I'm doing is I'm dividing that out of every piece. So I divide by 3x, divide by 3x, divide by 3x. Okay, so 3 divided by 3 is 1. That's gone. What's x to the third divided by x? X squared, right? So I have an x squared as my first term. Now negative 12 divided by 3 is negative 4. X squared divided by x is a single x. And then the last piece, 15 divided by 3 is positive 5, so plus 5. And then x over x cancels each other out. So I have 3x out front, Inside the parentheses, I have x squared minus 4x plus 5. Okay, any questions? So do you see how this is the reverse of double distribution? Or of just regular distribution? Can I show you something really quick that you don't have to write down? Okay? So you don't have to write this down. But if I distributed this back into the parentheses, 3x times x squared would make 3x to the third. 3x times negative 4x is negative 12x squared. And 3x times 5 is plus 15x. So I'm back to the original problem that I had up at the top, right? So hopefully that goes to show you that factoring is the exact opposite of distribution, okay? All right, so I want you to try these down at the bottom of that page, okay? Do the 4 try these down at the bottom of that page. Go ahead with your partners. Okay, so biggest number I can divide out of 8 and negative 12. 4. So my GCF is 4x squared. If I divide 4x squared into this piece, 8 divided by 4 is 2. I'm left with an x. Divide this piece by 4x squared. Negative 12 divided by 4 is negative 3. X squareds cancel each other out. So I have 4x squared parentheses 2x minus 3. Okay, number 4, I can divide a 5 out of every piece, and I can take an a out of every piece. So then I'm left, if I divide every piece by 5a. If you're struggling on these, make sure you go back and show your work of dividing by 5a on every piece. Okay, 5s cancel out. A to the 4th divided by a is a to the 3rd. Negative 10 divided by 5 is negative 2, and I'm left with an a. 25 divided by 5 is plus 5, and the a's cancel each other out. Okay, number 5, what's the biggest number I can divide out of 36 and 9 both? 9. Can I divide any variables out? No. So 36y divided by 9 is 4y. What's 9 divided by 9? 1. So make sure you put in your plus 1. Don't forget about that plus 1. It's important. Okay, and then lastly, the 4th piece looks like I can divide out a 6 and an h. So if I divide every piece by 6h, so 6 divided by 6 is gone, and I'm left with h to the 3rd. 12 divided by 6 is plus 2, and I'm left with an h. Negative 18 divided by 6 is negative 3, and the h's are gone. Okay? All right, can I get a comfort level on factoring out the GCF? Okay, let's flip it over to the next side and look at grouping, okay? Now, we are going to learn different factoring methods, and they all are very particular to a certain type of problem, okay? They're all very particular to a certain type of problem. Grouping only works when there are 4 terms, okay? So if you want to write that up at the top of your paper, that might be helpful. Only for 4 terms. This only works when I have 4 terms, okay? And the reason we want to group is because we're going to group the first 2 together, find the GCF. Group the second 2 together, find the GCF. And then we're going to do the GCF one more time. Okay, that's why I told you guys it's going to be a GCF party. Okay, so let's look at this. So I am going to group the first 2 terms together. So I'm going to group this x squared plus x together, and I'm going to do the GCF, okay? So what's the GCF of x squared and x? X. So I have x, and when I take an x out, I'm left with what? X squared divided by x is x, and then x divided by x is 1. So I have x plus 1 inside the parentheses. Okay, so that piece becomes x parentheses x plus 1. Does everybody see that so far? Okay, then I take the last 2 terms. So 2x plus 2. What can I divide out of 2x and 2? 2. So is it positive or negative? Positive. So I'm going to put plus 2. Okay, I'm going to put plus 2. And then if I divide a 2 into both of those pieces, 2x divided by 2 is x. And 2 divided by 2 is plus 1. Okay. Now, how many terms do you have? 2, right? This blue term and this red term. What do we look for when we look for a GCF? What are we looking for? Stuff that we can divide out of both of them, right? Stuff that they have in common. What do the two terms on the screen have in common right now? X plus 1, right? Both of these terms, this term has an x plus 1, this term has an x plus 1. That is the GCF. So, if I take the x plus 1, so it has an x plus 1, it has an x plus 1. If I take the x plus 1 out, what am I left over? Or what am I left with? X and plus 2. Second set of parentheses, x plus 2. I just factored by grouping, okay? All right, over to the side of your paper, I don't care where you put it, I want you to do x plus 1 times x plus 2. Okay? I want you to work that out. Make sure you're doing double distribution. Okay, did you all get x squared plus 3x plus 2? Okay, I want to show you some similarities really quick. Okay? So remember, distribution and factoring are opposites. So you see that I have a starting point, which is the same as my ending point, right? So if I'm doing opposite things, I should see some markers along the way. You can see my first step of double distribution is very, very similar to the middle step in my factor by grouping, right? And you can see that my final answer, well, not quite my final answer, but this answer right here when I have 4 terms is the same as when I had 4 terms at the beginning of my problem. Tomorrow, we will learn, or next class, we will learn how to go from 3 terms to 4 terms, okay? But right now, all you need to know is if you are ever given 4 terms or if you ever create 4 terms during a problem, you factor by grouping. You look for the GCF of the first 2, you look for the GCF of the second 2, and then you look for the GCF of the 2 terms you have remaining. Okay? All right, so let's look at example 2 together. Okay, so how many terms do you see? 4 terms, right? So let's go ahead and group. That's the only time we use grouping. So I'm going to group the first 2 together. So what's the GCF of 7ax and negative bx? What do they both have in common? An x, right? So I'm going to take an x out. If I divide x out of 7ax, I'm left with 7a. If I divide an x out of negative bx, I'm left with minus b. Then I group the last 2 terms. So I have 7ay minus by. So what does 7ay and negative by have in common? Just a y. Is it positive or negative? Positive, that's important. So now I have a plus y. If I divide a y out of 7ay, I'm left with 7a. If I divide a y out of negative by, I'm left with minus b. Do you see anything common to your 2 terms? 7a minus b. It has to be exact. So I have a 7a minus b. So I bring my 7a minus b out. And I'm left with what? X plus y. Here's your final answer. 7a minus b times x plus y. Okay, we have one more example here, okay? And this is when factoring by grouping can get a little tricky. So I want you guys to pay extra close attention here, okay? All right, so on example 3, I grouped the first two terms just like I usually do. 3y squared and negative 6y. So what can I divide out of 3y squared and negative 6y? Can divide a 3 out. What else? And a y. So I have 3y. If I divide a 3y out of 3y squared, I'm left with just a y. If I divide a 3y out of negative 6y, I'm left with minus 2. Always before, in all of our other problems, the stuff inside the parentheses have been the same, right? When I factor out my GCF. So that's your goal. Sometimes you got to do a little extra work to make it that way. Okay, let's look at our second two terms. So what can I divide out of a negative 4y and an 8? 4, right? So, don't write for a second. Okay, don't write for a second. Just look at my screen. Okay, so if I divided a 4, I want to do it on here so everybody can see it at home. If I want to take a 4 out of this, and normally we would just take a positive 4 out. Just watch what happens. So if I add or take a positive 4 out, what is negative 4y divided by 4? Negative y, right? And then what's 8 divided by 4? Plus 2. Are my parentheses the same? Is y minus 2 and negative y plus 2 the same? No, they're not the same. So, sometimes you got to do a little extra work. In order for me to get a y out of this term, what do I need to divide out? Because I want a y, right? The y is the first piece of my parentheses. So if I want to get just a regular old y out of negative 4y, what do I have to divide out? A negative 4, right? So I'm going to bring a negative 4 out, and let's see what happens. So you guys can write now. So if I divide a negative 4 out, negative 4y divided by negative 4 leaves me with just y, right? That's good. What about 8 divided by negative 4? It's a negative 2 or a minus 2. Now are my parentheses the same? Yes. So if you ever divide some or take a GCF out and you see that your parentheses are opposites, you know you need to go back and take out a negative, okay? And that'll fix it. So now my parentheses have a y minus 2 in common. So that y minus 2, I'm going to factor out that GCF, and I'm left with 3y minus 4. So y minus 2 times 3y minus 4 is my final answer there. Okay. Go ahead, take your time, work through the 4, try these with your partners. Go ahead. Okay, so out of the first grouping, out of the first 2, x, y, and 2y, I can bring a y out. So if I divide a y out, x plus y divided by y is just x. If I take the y out of 2y, I'm left with plus 2. I know I asked you this question already, but what is the GCF of x and 2? 1. 1 is the only thing you can divide out of both of those, so I'm going to take a positive 1 out, and that doesn't change it, so it just stays x plus 2. So the x plus 2 is in common, so I bring the x plus 2 out, and I'm left with y plus 1, so that's my second set of parentheses. So x plus 2, y plus 1. Questions on 1? Okay, number 2. So out of my first grouping, 12ab and negative 15a, I can divide a 3 out, and I can divide an a out because they both have an a in common. So 12ab divided by 3a is 4b, and negative 15a divided by 3a is minus 5. Then I do my second grouping. So out of negative 8b and 10, what can I divide out? A 2, I need to divide if I need to take the negative with it or not. So looking at my first set of parentheses, I need 4b in the first place. So what am I going to have to divide out of negative 8b? Am I going to have to take the negative or not? Yes, I am. And guys, general rule of thumb, if there's a, like 99.999% of the time, if there is a negative right here, you're going to take it out. Everybody see on the screen? 99.9% of the time, if there's a negative right here, you're going to factor it out. Okay, so I have a negative 2. If I take negative 8b divided by negative 2, I'm left with positive 4. b, and 10 divided by negative 2 is a negative 5. My parentheses are the same, 4b minus 5, so that comes out front. And I'm left with 3a minus 2. So 4b minus 5, 3a minus 2. Questions? Okay, let's do 3 and 4. I'll go through a little quicker here. So out of my first grouping in 3, I can bring an x out, and I'm left with x plus 3. Second grouping, I can take a positive 4 out, and I'm left with x plus 3. X plus 3 is in common, so I bring the x plus 3 out front, and I'm left with x plus 4. You can see after you practice this, they get to be pretty quick little problems. Okay, until you run into a hard one, kind of like number 4. Can I move on to number 4? Are we good? Okay, it's a little more confusing. So out of the first grouping, looks like all I can take out is an x. So x squared divided by x is x. Then I'm left with minus 2a in the second term. Out of the last two terms, remember if there is this negative in the middle, I want to take that out. So a negative 3 and an a. So I'm going to bring out negative 3a. So negative 3ax divided by negative 3a is just the x left over. And then if I divide this last piece by negative 3a, it looks like 6 divided by negative 3 is a negative 2. A squared divided by a is left with an a. So then my parentheses are the same. I can bring them out, x minus 2a. And I'm left with x minus 3a. Okay. Any questions before we rock and roll with homework time? No? Okay.